Hey guys, thanks for tuning in. Today we're going to unbox, set up, and do the initial test prints on the Artillery Genius. So in simplest terms, you can think of the Artillery Genius as the baby brother to the Artillery or Evnovo Sidewinder X1. They did change their brand name at a certain point in time to Evnovo, but this one came labeled as Artillery, so maybe they've gone back to that. Okay. So we've got an installation manual, and this thing is about 110 pages long or so. Just like the Sidewinder X1, they include this little pouch of USB cable, some spare ribbon cables, and spare wheels, wrench, etc. Power cord, the spool holder with bearings, and the filament runout sensor that goes on the top cross member. The entire upright assembly, and it is a synchronized Z-axis dual Z lead screw. Some people love or hate the synchronization of the dual Z. The nice thing is that your X-axis will never get kind of out of canter, where one side kind of sags, or if you're pressing on one side, it goes down and now you're all out of whack. They will always move in unison. It will always be completely perpendicular to the uprights or parallel with the bed. So buried under all of this foam is the base, which also houses the power supply and all the electronics. Do not remove this before you've finished assembly to protect the heated bed and that textured surface that is great for adhesion. So assembling this is pretty darn easy. So we have the uprights here. They fit into these little grooves. Oops. Make sure you don't crush a cable in the process. So they fit in right like that into these little cutout notches here. And we have the cables kind of taped to the base. It's pretty obvious where this goes. It only fits in one spot, so it's going to go in the motor. Click. Same with this side. And I'm kind of getting ahead of myself, admittedly, because I haven't even bolted it in yet. All right. So then we'll take the long M5 bolts that are in this bag with the Allen keys. And ideally we should put a lock washer on them as well. And then they run up underneath the base through there's a little cutout channel under there and into the uprights. It's easiest to do this, I find, hanging off the edge of a table, and then I can easily access it from below. So two more in the other side. All right, so that's pretty stable. It's actually the table wobbling, not the printer. And at this point, I'm just going to remove this paper because it's kind of bothering me. So this is much like the Sidewinder X1. This is an AC heated bed with a silicone heat mat underneath there. In our region, we're using 110 or 120 volts, not 220. It comes with a direct drive extruder using a Titan style extruder mechanism, so a 3-to-1 gear ratio. And the block on here is a volcano style block, so it takes the longer E3D V6 nozzles. We'll have to open up and double check if it is an all metal heat break in there. The Sidewinder X1 came with a PTFE lined heat break. So before you run higher temperature materials above 250 or so, you're gonna want to double check your heat break. Flipping it back around, so I already plugged in the wires for the dual Z stepper motors, and the other wire that's taped to the base is for the Z axis end stop, So right here, there is an inductive sensor for the Z-axis end stop. So it is not a micro switch like you might have on many others. So it just senses the presence of the metal in close proximity and lights up when it senses that and sends the stop signal. So let's plug that in. It's using a keyed plug, so it only goes in one direction, one orientation. And then on the other side, right here, there is this little cable that leads up to here. This is for the filament runout sensor that is attached to the spool holder that I mentioned earlier. And so it's kind of hard to see maybe from that perspective, but this plugs into the base of the unit right here beside the stepper motor, or kind of in front of the stepper motor. And once again, it's also keyed. There. So a couple things off the bat that I already like a little bit more, or see them as improvements to what I saw on my Sidewinder X1. They're minor things, but they're kind of quality of life improvements. Right here, the cutouts for the USB and micro SD slot, there is like zero gap around them. So on the original Sidewinder X1, this was one large cutout, and you could quite easily drop your micro SD down inside the control box and then have to take it all apart to get it out. So it's nice to see that. It was a quick print to print a little bracket that kind of took up that extra space on the original, but that's kind of nice to see. So let's cut off these zip ties. Being careful not to hit the ribbon cable in the process. There we go. Okay. And peel that off. All right. So now the spool holder, they've changed, another quality of life improvement, if you will. They've changed the way this mounts onto here. So on the original, you had the two parts of the spool holder like this and like that. So we're at the back of the printer, obviously. And they bolted in to the extrusion through the back. So then whenever you had a smaller spool, maybe you had a 500-gram spool, you'd have to unbolt this, kind of shimmy it down, bolt it back in. So what it looks like they've done here is just given you a slot within which this side can kind of slide. This one stays stationary. Honestly, it's not falling off front or back, so it doesn't need to be bolted in or anything. So that makes adjusting for different size spools a lot easier, especially since, if you're running this against a wall or something, reaching a screwdriver or a Allen driver or Allen key around the back, you might have to spin the whole printer around, and it's just a hassle that you don't have to deal with anymore. So let's wire up the filament runout sensor. Just plug in the last cable. That should be it. So the filament runout sensor can kind of pivot in multiple directions here, so that it can move with the spool. And so you run your filament from the spool through the filament runout sensor. There is an arrow, so it has to run in that direction like that. And then that will go to the extruder. So this allows it to kind of follow the extruder left and right like that. So personally, I'm a little bit curious, as always, what makes my printers tick. I suspect that this is an MKS Gen L board in here, much like the Sidewinder X1, but we're going to take a look. Warranty void if seal is broken. That's fine. So now we're going to unbolt 1, 2, 3, 4, 5, 6 screws. So on the bottom, just before I unbolt it, we have a large cooling fan and just enough slack, perfect. Be careful because it easily pops out of that socket right there. And yeah, we've got MKS Gen L board there. This is a TFT32, I think, touchscreen. There's two pieces of like thermal mat, like under the bed here on top with a power supply. Not entirely sure what the point of that is. It would be pressing against the bottom of here, so maybe to make that feel more firm or less wobbly. There's just a standard 24 volt, 150 watt power supply. It's not like not a mean well or anything. You have an SSR, so that's to switch on and off your AC heat bed. And then some nice wire management, to be honest. A lot of the cables, I mean, you may have seen the ribbon cables that are for the Z and the X. They're both ribbon instead of your standard bundle of normal wires. So they have these breakout boards. So there's a breakout board here that breaks out the ribbon back to normal wiring. And then there's a breakout board on the X here underneath the cover, and another breakout board on the hot end assembly that's moving back and forth. So now we're going to button this back up. Let's just make sure that we plug this fan back in. Some of these connectors have hot glue on them to make sure that they don't just pop out easily like that one, but this one doesn't. So just be sure that as you lift this back up, you plug it back in. So that breakout board under there leads to the ribbon cable. The ribbon cable comes out here to another breakout board that then has a breakout for the wire for the motor, also a wire for the inductive end stop there, the X-axis end stop, and then leads to another ribbon cable that goes over here to the hot end to another breakout board that then goes to all the components of the hot end. So this accomplishes a few things. Number one, these ribbon cables constrain the wire path. So it acts much like a drag chain or cable chain would to make sure that your wires are, bending in a nice radius and constrained to a certain path and space so they don't get tangled in anything, and it looks nice and neat. It's a love-hate relationship though. The Sidewinder X1 back in the day had issues with the ribbon cables where they were running too much current over them. So if you're running too much current over these tiny little wire leads in these cables, you can end up burning out the pins in it. They solved that by running that voltage, it's actually amperage that burns them out, but running that current over more leads in there, therefore spreading out the load among more of the pins in the ribbon cable. That was specifically for the hot end. It was drawing 60 watts. At 24 volts, 60 watts is about 2.2 or so, 2.4 amps, and it was drawing it maybe over 3 pins or something. I think they switched to 4. But it's something that when designing and using ribbon cables, you have to, like all cables, you have to keep in mind the current ratings for the wires that you're using. But when done properly, it looks nice and neat. I haven't had mine wear out, and I've run thousands of hours on my X1. I would expect the Genius to last just as long. There we go. So we're about to do our initial prints, but before we get to that, we should probably make sure that we've adjusted the wheels on the printer. So sometimes they're shipped rather loose. We have 4 wheels on the bed, 2 on either side. The 2 on this side have an eccentric nut. I'll demonstrate on the hot end assembly here in a second, but you can use your wrench to twist that eccentric nut to apply more pressure from the wheels to the rail in the center here, the 2040 Y rail. But you want to make sure that the way I test it is that if you roll any wheel by hand, that all the wheels are making contact and rolling. So as I said, we'll demonstrate this with the hot end here. So if I roll this wheel, it's just sliding with 0 pressure against the rail. Likewise with this one, so that's no good. Because we have the Z-Sync belt up here, I can actually just turn either one of these and both will turn. Normally you would want to make sure that you move these equally, otherwise you'll end up kind of off kilter like that. I'm just going to give myself some clearance because the eccentric nut is on the bottom wheel here. Sometimes this is so bad that the whole, well, this one actually demonstrates that, the whole hot end can kind of jiggle back and forth. And you can imagine if you're printing and it's moving side to side, that jiggle will translate into your prints in spectacular fashion. So take our wrench and hook it onto the eccentric nut, and I always kind of have to play to figure out which way to turn it to apply pressure. That's the direction. Just make sure you don't smack the bed. I'm probably going to move it up higher. There we go. There. So I move this wheel. They're all moving equally. And if I move this side to side slowly, you don't want to move this quickly because that motor is acting like a generator feeding electricity back through the board. It moves smoothly. There's no bumps or detents in the motion, so that's good. And they're all putting equal pressure on the rail. So do the same with the bed. The bed is much harder for us to show you. It's kind of close quarters in there. But just by reaching my hand in, I can see that all four are contacting the rail. There's no slop in the bed. I will add some preload to the bed springs. Just tighten them down to bring the bed a little bit further down, make sure we have good clearance. And then when this is lowered all the way down, touching the Z end stop over here, there. The nozzle is just a millimeter or so above the bed. So now I can go through the standard bed leveling routine on the screen and go corner to corner and level the bed with those knobs manually. All right, so we're gonna do our initial bed leveling. We'll go to Tools, we'll go to Heat, and then you can see we've selected the extruder. E1 is currently 18 degrees or so, a little chilly in here, and it's set to 0. So let's add some to that. This button here allows us to change the increments, so 10 degrees, 1 degree, 5. So we're gonna add 10 at a time. We'll go to 210 degrees. And then if we hit extrude 1, it'll switch to bed. And again, we can see the current temperature and set temperature. We'll do it in 10 degree increments, and we'll set the bed to 70 degrees. If we get out of these menus, we should see both of those temperatures in a minute reflected on here. There we go. So both are heating up. If we go back in Tools, while we're waiting, we can just home all axes. Okay. And as you can see there, hopefully, we have still quite a bit of clearance between the nozzle tip and the bed. We do have filament loaded and it has oozed out of the nozzle a little bit, so we'll want to clear that piece of filament before we actually go and bed level. So let's move the Z up. And then as it heats up, I'm going to actually back this filament right out just so it doesn't ooze. And yes, that is hot. Okay, let's get out of here. So we're at 204 degrees and 70 degrees on the bed. So I've got a piece of just regular printer paper. I go to level, and then there are quick set points to each corner. So I'll hit first. So it goes a little bit inset from the front corner. I'll just check the drag, adjust the bed, and then jump to the second point. Okay, third. Way too tight. Okay, and then the final check is the point in the center. It's actually pretty good as well. So I'm just going to go around one more time, just make any fine adjustments as needed. Okay. All right, so now that we're leveled, we'll just stick the USB stick in the top of the machine by the screen, go back out to the main menu, we'll go print, and then we've got a couple things that are sliced up, so let's just print them. So here we are, we have 3 test prints, and I must say these prints are completely out of the box, no tuning, no calibration, nothing, just using our typical slicer settings that we would use for a direct drive machine. This is direct drive. I know when a lot of people got the X1, they were still using like 7 millimeters of retract from their CR10 or similar Bowden setup. We're using about 1.2 millimeters of retract with PLA on this guy. So we have this print in place little lizard, turned out great. We have this Frankenstein statue, and What's interesting to note is I know especially when the X1 was originally released, there was a lot of Z banding kind of issues. That's all seemed to be resolved right out of the box. This turned out perfect. And then we have the owl that we've used many other times, and also that turned out very well. We definitely could work on our maybe some coast or some wipe at the end of our layer lines to hide that seam a little bit, but we did random seam here, so it is kind of scattered about. So hopefully you found that useful. Remember to like and subscribe and ring that bell to get notified when we upload more videos like the Artillery Genius. Thanks for watching.